Hey everybody. Today we're getting some practice computing trig functions of any angle. We're going to do 3 problems. Here they are. In each case, the strategy is the same. First, draw the angle in standard position using coterminal angles if needed. Then, draw a right triangle using the x-axis and the terminal side of that angle. That's called the reference triangle, and the acute angle at the origin is called the reference angle. Then we'll compute the trig function of the reference angle just using right triangle trigonometry. If we need to, we'll change the sign, the plus or minus, of the result based on the quadrant of the original angle. Problem 1, find cosine and sine of negative pi over 6. Drawing that in standard position, we get this. We see that the angle is going to be in the 4th quadrant. So now we draw a reference triangle. We take that point, x comma y, that's picked out by that angle on the unit circle, and connect it to the x-axis with a perpendicular line. We can see that in this case we have a pi over 6, pi over 3, pi over 2 right triangle, also known as a 30, 60, 90 right triangle. So the side lengths have to be 1/2, root 3 over 2, and 1, just based on our knowledge of 30, 60, 90 right triangles. Since we're in quadrant 4, the x value has to be positive and the y value has to be negative. So the coordinates of that point are root 3 over 2, comma, negative 1/2. The cosine of the angle is going to be the x value, and the sine of the angle is going to be the y value. So in this case, the cosine of negative pi over 6 is root 3 over 2, and the sine of negative pi over 6 is negative 1/2. Problem 2. Find tangent and secant of 85 pi over 4. So this angle is a little harder to sketch. I don't immediately know what 85 pi over 4 looks like. We want to start by finding a convenient coterminal angle by subtracting multiples of 2 pi until we get to an angle that we do recognize and that we can easily sketch. Basically, this means finding a multiple of 2 pi that's close to 85 pi over 4. So here I'm going to use the fact that 2 pi is 8 pi over 4. That's 1 rotation around the circle, so that's always going to give me a coterminal angle. So a multiple of 2 pi close to 85 pi over 4 will be 80 pi over 4. That's 10 full rotations of 8 pi over 4. Now we subtract that from 85 pi over 4. In other words, subtracting off those 10 rotations, and we're left with the coterminal angle of 5 pi over 4. This is a little easier to sketch. It's in quadrant 3. Once again, we want to draw the reference triangle. So in this case, we get an isosceles right triangle. The reference angle is pi over 4, so we've got a 45, 45, 90 right triangle. The side lengths of that triangle have to be root 2 over 2, root 2 over 2, and 1. We're in quadrant 3 this time, so both the x and y coordinates have to be negative. So the coordinates of that point are negative root 2 over 2, comma negative root 2 over 2. Tangent is y over x, so the tangent of 85 pi over 4, the same as the tangent of 5 pi over 4, is 1. And the secant 1 over x of 85 pi over 4, so the secant of 5 pi over 4, is going to be negative the square root of 2. Problem 3. Find cotangent and cosecant of 11 pi over 2. Again, we want to find a convenient coterminal angle to start off. We want to subtract multiples of 2 pi, also known as 4 pi over 2. So a convenient one is 12 pi over 2. That is going to be 3 full rotations. So when we subtract that off from our angle, 11 pi over 2, we get negative pi over 2. Here it is, drawn on the unit circle. This corresponds to a point on the negative y-axis. We don't have to draw a reference triangle this time. The coordinates of the terminal point are obvious. It's a unit circle. We're looking at the intersection of our angle on the negative y-axis, so clearly the point is going to be 0, comma, negative 1. Cotangent is x over y, and cosecant is 1 over y. So the cotangent of our angle in this case is going to be 0, and the cosecant is negative 1.